Hello, and good afternoon, good morning, or good evening, wherever you are attending this conference from. Thank you very much for attending this presentation and for the opportunity to share my research with you. This is a joint effort with Michael Lederby from Pontificia Universidad Católica and Patricio del Sol. And I want to specially thank Startup Chile for facilitating the data for this research. So, the title of our research is actually a task that many organizations nowadays aim to do and refers to what extent can we predict entrepreneurial performance under uncertain environments and by which means. So, what we look at in our study is at the performance of 4 different methodologies to do so, which are coexisting nowadays. So let me jump straight forward to the research gap. So imagine you're faced with a strategic decision in a fast-moving and uncertain context, or entrepreneurial context in another word. Well, to this point, current literature has addressed this decision-making problem from 3 angles: from a heuristic point of view, from an economic approach, and using machine learning modeling. And in these 3 programs, we identify some sort of tensions that could not guide us to answer our question, what is the best tool to perform our task? So, from the heuristic program point of view, on one side, we have scholars telling us that they are good and we should use them in strategic and uncertain contexts. But on the flip side, others argue they lead to biased decisions. When looking at machine learning modeling, we also have contradictory evidence, because while some prior literature points out that they are good because they allow for the usage of many predictors, other scholars argue that using fewer predictors actually lead to better performance in uncertain and fast-moving environments. And finally, from a human expert rationale, there is prior literature that proposes 2 basic methodologies to predict performance, be they a judge-based approach and econometric modeling. And their evidence points out that while economic modeling outperforms most widely used criteria relying on judges, they also argue that their predictive models lack prediction power and tend to explain the past rather than predicting for the future. So, what is our research questions? To this point, nobody has pitted rational heuristics against other decision-making methods. So we ask ourselves, do rational heuristics outperform other tools in entrepreneurial settings fraught with uncertainty? And well, to answer this question, we set out to measure how does a set of simple and thoughtful rules perform against traditional and burdensome methodologies. And why is this important? Well, we have 3 different possibilities here. First is the case in which rational heuristics are good and they actually help performance. So we look deeply inside this rationale to perfect our decision-making processes. On the flip side, it could be that rational heuristics actually hinder performance, and in that case, we should take a deeper look at these phenomena to prevent from using them. And finally, another option is that rational heuristics actually perform the same as current methodologies. And in that case, well, we might as well know more about them as they bring many other benefits because they are fast, cheap, and help organizations in many other ways. So, so we broadly want to know whether we can predict entrepreneurial performance. And you can think this about from the perspective of public funding agencies or investment funds seeking economic development or job creation. But our research specifically focuses on how does a set of simple and thoughtful rules perform against traditional and burdensome methodologies at predicting entrepreneurial performance. And to answer this question, we compare a set of rational heuristics against three different methodologies, be they a judge-based approach, an expert econometrician approach, and a machine learning approach. And let me further explain the extent of these approaches in a couple of slides forward. So, early on suggestions have been made that strategies should use simple heuristics to make predictions about key decision variables. And more recently, strategy scholars have provided empirical evidence that strategies indeed use heuristics as simple rules. And these rules are often learned from and honed with experience, and that their use often leads to better decisions. So, while the literature on heuristics can be divided into three main programs, what I want you to focus on is that while the first two programs focus on universal heuristics that typically emerge automatically at an individual level, the third one focuses on unique heuristics that emerge from thoughtful reasoning. And while the first program focuses on the negative implication of the bias induced by the use of heuristics, the last two programs focus on the positive consequences of their use. Moreover, recent research um, claims that strategies to learn heuristics that accept a bias, that is a systematic deviation of predictions from actual outcomes, can outperform unbiased strategies because they can reduce the variance component of prediction error, which is the degree to which random fluctuations in observational data are inappropriately generalized. And the few empirical papers we have are case-based and suffer from potential omitted variable bias. So, well, now, looking at prior literature that uses machine learning in a strategic context, it points out that machine learning methods are designed specifically for out-of-sample prediction and are less reliant on human judgment. But while they have the potential for identifying patterns that might be too subtle to be detected by human observations, the use of models with many free parameters tend to increase the variance component error, hindering overall prediction performance. When looking at human expert judgment prediction tasks, we are faced with two options. A judge-based criteria, which is costly and time-consuming and can lead to discriminatory decisions or be driven by overconfidence, or an econometric point of view, where complex strategies involving economic modeling have been shown to be superior to less information-intensive approaches. But some scholars argue that this is due to the predominant use of various methods of fitting rather than predicting. So, prior literature points out that economic models based on few key variables selected by economists have shown to do better than the judges in predicting some future success outcomes. However, these models still only explain a small fraction of the variation on key outcomes. So, our methodological approach relies on the comparison of four different methodologies to identify which companies will be more successful, which are the ones I just told you about: expert judging criteria, inference model used by economists, machine learning modeling, and rational heuristics. So, our judges approach research setting consists of a panel of three expert judges that assess independently each application to yield a final mean score. And they assess each team member entrepreneurship potential in four fundamental areas, where the highest scores are awarded to those participants that the judges identify as having greater probability of success. The first two areas evaluated by the judges relate to the project regarding the product or service offered and its competitive and marketing positioning, and the remaining two areas relate to the team regarding its composition, qualification and experience, and also in relation to its networks, obtaining a final weighted score. For our ad hoc inference models, we followed prior literature that points out that economists can develop business performance predictive models using econometric modeling in strategic entrepreneurial settings. And mirroring their work, we used personal background predictors such as gender, age, educational level, geographic location, industry, risk aversion, and ability. And finally, inspired in prior literature in our machine learning research setting, we evaluated the performance of three different methodologies, be they gradient boosting classification, super vector machines, and classification and regression trees. And we fed all the detected independent variables we had to the algorithms, totalizing around 225 predictors. For our rational heuristics research setting, we constructed 9 rational heuristics as simple rules. We measure the feasibility of the idea for a maximum of 2 years, whether the team had developed an MVP or not, if the opportunity emerged from either a technological change or a market change or both, and if they had acknowledged the uncertainty in their projects. We also assessed if all team members had graduate education and if they had grown expectation through reasonable internationalization. Finally, we measure the extent to which the team's prior experience matched their entry industry and country, and if whether all team members had entrepreneurship experience. So, our dependent variables account for short-term performance in the form of entering a showcase event 6 months later, which was our demo day variable. We also measure public and private capital, yearly sales, and total number of employees. It is important to notice that as our outcome variables are dichotomic and signaling whether the startup is in the top 10 percentile of that measure or not, we're facing an imbalanced data set. And this is important because we enter a problem where usual classification metrics fail to prevent the obvious and dummy behavior, which will be to classify all observations as rejected, reaching outstanding 90% accuracy due to correct classification of only the negative class. So, in summary, we conducted a field study. We had performance metrics unconfounded with initial evaluation and a large sample. And the key takeaways I want to tell you about are that for the predicted power of the set of simple rules, we found that it outperforms all other approaches when predicting for private capital raising. It performs better or equal to a judge-based approach for all other outcome variables, and it performs better than econometric approaches for all other outcome variables. So, for our research setting, the ideal research setting will be an organization that needs to make many opportunity capture decisions about entrepreneurial opportunities in a highly uncertain environment. And in this ideal research setting, we will be able to compare the performance of these different decision-making methods. Therefore, we chose Startup Chile Ecosystem Accelerator, which twice a year has to evaluate about 1,000 startups and has to choose nearly 100 to accelerate each time in a very short period of time. So the selected startups are given a 6-month tenure, 40,000 grant with a co-working space and entrepreneurship schooling. We evaluated 8 cohorts, totalizing 674 startups. Our demo day showcase outcome was captured 6 months later, and our private and public capital raise, sales and employees measure, was captured roughly 2 years later. So, for our empirical analysis, wrapping up, we pitted a complex judge-based model, a complex retrospective econometric model, a complex machine learning model against our traditional heuristic model as simple rules. To construct our decision model, we fed it with our 9 rules based on theory and experience. The assembly of the rules was refined using classification and regression trees, which is a supervised machine learning methodology based on the concept of Bayesian updating, which mirrors the decision-making process described by Gigerenzer, inferring the decision tree from correlation between antecedents and performance outputs. So, to go deeper into the results, I must first discuss our metrics. We relied on the F-beta measure, which is a generalization of the F measure that adds a configuration parameter called beta. The default beta value is 1, which is the same as the F measure, the classical one, and works fine when dealing with balanced datasets. A smaller beta value, such as zero 0.5, for example, gives more weight to precision and less to recall, putting more attention to false positives, whereas a larger beta value, such as 2, gives less weight to precision and more weight to recall in the calculation of the score, putting more attention to avoid false negatives. Because in our setting, it's much more worst missing a promising opportunity than allowing into the program a less important one. So now, for the results. When looking at demo day entrance, we can see that judges scoring is highly related to making it into the demo day. Although our heuristics approach proves to be quite competitive at the same task, surpassing the ability of econometric and machine learning models. Regarding the amount of public capital raised, we can see that the judges' scoring is again highly accurate. This makes sense because Startup Chile, as a government accelerator and public funding, chooses which project to finance by what these judges decide. It is interesting that the ability to do the same task for a machine learning model is similar and in cases higher. This suggests nonlinearities and complexities behind the data that predict public capital raising and that the machine learning models are capable to detect. For private capital raising, we can see that our set of heuristics surpasses by far the performance of human expert judgment approaches. And the fact that our rational heuristic models get surpassed in its ability by a machine learning model suggests that there is still some information and nonlinearities among the predictors we fed them. that help to predict ability to raise private funding. But it's not being captured by our set of heuristics. We can see again that our set of heuristics surpasses the performance of human expert judgment approaches. And again, the fact that our heuristic-based approach gets surpassed by the machine learning approach suggests that there's still some information and nonlinearities among the predictors that are being captured by our set of heuristics. Finally, when predicting for future employment growth, we get the same pattern. Our set of rational heuristics is capable as a judge-based approach to predict employment growth, and the ability to do the same task for a machine learning model again is higher. So, in summary, in an entrepreneurial strategic context, the judge's approach can predict whether other judges will judge favorably as well. A rational heuristics approach outperforms all other approaches when predicting for private capital raising. It performs better or equal to a judge-based approach when it comes to predicting demo day entrance, public capital raise, sales, and employment. And it performs better than econometric approaches for all of these outcome variables. So, to this point, few empirical papers have supported the logic of the development of rational heuristics as a capability that can effectively help firms achieve superior performance. And we shed light into this matter, providing empirical evidence supporting this logic. For the next steps, we're looking at studying which predictors fed to the machine learning approaches provide the insights that our heuristics approach lacks when predicting for day-to-day business activities like public capital raising, sales, or employment. And we also aim at answering whether we can proxy this information in the form of a new heuristic that improves the performance of our heuristics approach. So thank you again for your time, and I hope this study can shed light into yours.